Good morning, good afternoon, and good evening. This is Mr. Payne bringing you Unit 1, Lesson 1, Rates, Patterns, and Problem Solving. Algebra at its core is all about using properties of real numbers to manipulate unknowns, called variables. Algebra is used to recognize patterns, turn them into mathematical relationships, and then use these relationships for useful purposes. I want you to underline key vocabulary. The first key vocabulary word you're going to learn today is variables. It is when a letter is used to represent an unknown number. Let's look at exercise number 1. If there are 12 eggs per carton, then how many eggs do we have in 5 cartons? So one of the things that I want you to get in the habit of is identifying your proportions. So I have eggs over cartons, and I'm going to abbreviate. So I have 12 eggs for 1 carton. How many eggs do I get in 5 cartons? If you do this, everything stays nice and organized. So now, because it is a proportion, you cross multiply. X times 1 gives me X. 12 times 5 gives me 60. And make sure we label, and we are talking about eggs, so we have 60 eggs. Let's go to B. If a car is traveling at 65 miles per hour, then how far does it travel in 2 hours? 65 miles per hour, so you go 65 miles in 1 hour. So I have miles over hours. How far can he travel in 2 hours? How far does he travel? So that's miles, that's my X. 2 hours, 2 is going to go with hours. Same thing, proportion, cross multiply. X equals 130 miles. If a pizza contains 8 slices and there are 4 people eating, how many slices are there per person? So I have 8 slices divided by 4 people, which gives me 2 slices per person. D. If a biker travels 20 miles in 1 hour, how many minutes does it take per mile traveled? I'm going to do 20 divided by 60. The reason why it's 60 is because it's 60 minutes. It's not just 1 hour. So it's 20 divided by 60 is going to give me 0.3 miles per minute. Rates show up everywhere in the real world, whether it's your pay per hour of work or texts you can send per month. Rates are all about multiplication and division because they ultimately are a ratio of 2 quantities, both of which are changing or varying. Exercise 2. A runner is traveling at a constant rate of 8 meters per second. How long does it take for the runner to travel 100 meters? Experiment. Solving this problem by setting up a table to track how far the runner has moved after each second. So I have my table of x and y values. After 1 second, he has traveled 8 meters. After 2 seconds, traveled 6, or 16. After 3, you have 24. 4, you have 32. Notice what I'm doing here is I'm going up by 8s. 5, I have 40. 6, I have 48. 7, I have 56. And so forth and so on. You can continue this table on your own. B, it says, create an equation that gives the distance d that the person has run if you know the amount of time, t, they have been running. So the formula is d equals r times t. Now set up and solve the simple algebraic equation based on b that gives the exact amount of time it takes for the runner to travel 100 meters. So d is my distance. He's traveling 100 meters at 8 meters per second. That's my rate. And I want to know how much time it's going to take. So if I set it up as 100 equals 8t, I divide by 8 on both sides. My time is going to give me 12.5 seconds. The table would get you to the same answer the long way. The expression or the equation and the formula get you there a little bit quicker. In exercise 3, I'm going to show you how and why that formulas are a little bit better than drawing a diagram, but a diagram will never hurt. Exercise 3 says a man is walking across a 300-foot long field at the same time his daughter is walking towards him from the opposite end. The man is walking at 9 feet per second and the daughter is moving at 6 feet per second. How many seconds will it take them to meet somewhere in the middle? So I have my father on this side and the daughter on this side. It says that they want to meet somewhere in the middle. Well, if my field is 300 feet long, 150 would be somewhere in the middle. And that would be 150. The father is moving at 9 feet per second. So if I'm moving, every dash is going to be a second, so that's 9. It's going to be 18. And you keep going, 27 feet in 3 minutes now, because it says feet per second that the daughter is moving. So that's 1 second, 2 seconds, 3 seconds, and you keep going to see how many seconds it takes in order to get to 150. And then on the daughter's side, you have 6 feet per second. So 6, 12, 18, and so forth, 24, and you keep going until you get all the way to 150. And that's 1 second, that's 2 seconds, that's 3 seconds, that's 4 seconds. And you can continue drawing that table. What must be true about the distances the two have traveled when they meet somewhere in the middle? And that's question B, or option B here. Well, we know that the father is traveling a little bit farther per second, feet per second. So he gets to the middle the fastest. But he also travels a little bit farther than the daughter. So it says C, create equations similar to exercise number 3 to predict the distance the father has traveled and the distance the daughter has traveled. Predict the distance the father has traveled and the distance the daughter has traveled. There's a mistypo in there. So I have 300 total feet. And in order to get to those feet, I have 9 from the father plus 6 from the daughter. So if I combine those, I have 300, which equals 15x. Divide by 15. X is going to equal 20. But now I have different values for my father and different values for my daughter. So I have my father here, and I'm going to have 9 times 20, which is going to give me my distance of 180 feet. And my daughter is going to give me 6 times 20, which is going to give me 120 feet. Notice what I did, and this is common. You may see train questions this way. You put your total distance, and my 9x represents my 9 feet per second, and my 6x represents my 6 feet per second for my daughter. And I add them together because I know the total has to, when I add them together, will give me 300 feet. D says, create and solve an equation to predict the exact amount of time it takes the father and daughter to meet in the middle. So I have D equals rate times time. 150 equals 9t. That's for my father. And that's going to give me, t is going to equal 16.7 seconds. And I'm going to use the same formula for my daughter. So D equals RT. My distance is 150 because we're meeting in the middle. My rate is now 6 seconds. So now I'm going to divide by 6 on both sides. And it's going to give me 25 seconds. This whole entire question from exercise 3 can be done by the diagram and making a nice, neat, organized diagram. It also can be done by using the D equals RT formula and an equation to solve that. Please now write your WSQ, talking about some little hints that I gave you on setting up proportions and what is important when setting up proportions. Have a great evening.